What if the moment you are experiencing right now is already millions of years old? The light reaching you from the nearest large galaxy, Andromeda, set off 2.5 million years ago. But the real shock is how easily time itself is destroyed. Travel close to a black hole, and due to extreme gravitational time dilation, a journey that lasts mere weeks for you could mean the entire rest of the human history has played out on Earth. Time is not a universal constant. It is a river whose current is warped by mass. Furthermore, the immense size of the universe means that the probability of cosmic repetition is terrifyingly high. Is the present merely a local delusion, and does the sheer scale of the cosmos mean that an exact copy of your life is playing out right now in a distant, unobservable region? For as long as humanity has looked up at the night sky, the moon has appeared eternal calm, unmoving, a silent guardian, suspended in darkness. But behind that illusion of stillness lies a quiet cosmic drama. Modern measurements reveal a startling truth. The moon is slowly escaping us, drifting away from Earth by 3.8 centimeters every year. It is a movement so small we cannot see it, yet so powerful it reshapes Earth's rotation, rewrites planetary history, and opens a doorway to one of the most intriguing mysteries in celestial mechanics. Something subtle, ancient, and unfinished is unfolding above us, and we are only beginning to understand it. What do you think is really causing the moon to quietly drift away from Earth? Share your thoughts in the comments below. The strange thing is, if today's recession rate had been constant for 4 billion years, then in the early days, the moon must have been so close to Earth that it nearly touched the surface. This is clearly impossible. That means the recession rate has changed continuously, sometimes slow, sometimes fast, then slow again, in ways science still does not fully understand. And from this point, a series of major questions, paradoxes, and gaps in our understanding of the shared journey of these two celestial bodies begins to unfold. First, we must understand that the moon recedes because of tidal forces. As Earth rotates, the oceans are pulled slightly off-center by the moon's gravity. This offset creates torque that slows Earth's rotation while pushing the moon farther away. The process is similar to throwing stones on a lake. Each throw spreads the water outward. But the central question is, why is this pushing away not constant? Why are there periods when the recession rate increases dramatically? Why are there periods when it nearly stops? What kinds of changes cause the moon to experience such irregular phases in its long journey? Part of the answer may lie in Earth's geologically turbulent past. Our planet has never maintained the same configuration. Its oceans were once deeper or shallower, wider, or more restricted over cycles spanning hundreds of millions of years. Supercontinents such as Rodinia, Pannotia, and Pangaea formed and broke apart, repeatedly, constantly reshaping the distribution of water across Earth's surface. These configurations determined how tides propagated, how quickly waves responded, and how much energy the oceans transferred back into Earth's rotation. Yet the most puzzling point is this: even when all these geological changes are included in models, the calculated variations are still not large enough to explain the strong fluctuations in the moon's recession rate recorded in ancient sediments. This discrepancy suggests that additional unidentified factors may still be influencing the Earth-Moon system. A famous paradox arises from sedimentary rock records showing that around 1 billion years ago, a day on Earth lasted about 18 hours. This means the moon was significantly closer than it is now, but the recession rate at that time does not match modern models. There were periods when it receded much faster than it does today, and other periods when it nearly stopped. Scientists call this the missing energy problem, meaning Earth's rotational energy did not change as theory predicts. One significant line of explanation involves Earth's climate fluctuations. During ice ages, when the planet's surface was covered by massive ice sheets, the shape and depth of ocean basins changed dramatically. These shifts altered the way tides propagated, potentially weakening or intensifying tidal energy feedback and causing the moon's recession rate to speed up or slow down unexpectedly. Climate tide geology models show that ice ages do have a real influence. Yet the puzzling part is this: even the most sophisticated simulations still cannot fully reproduce the strong variations in the moon's recession rate recorded in ancient geological archives. This indicates that climate is only one component of a much larger mechanism that remains unknown to us. Some scientists suspect that part of the answer may lie deep within Earth itself. They propose that if the rotation rate of the inner core changes cyclically, or if unusual friction occurs at the boundary between the core and the mantle, the flow of energy from Earth's interior to its surface could be subtly altered. These small but long-lasting variations might influence tidal strength, thereby modifying the moon's recession rate during certain periods. However, this idea remains purely hypothetical, as current geophysical evidence is still insufficient to confirm such a mechanism. What makes the story even more mysterious is that the moon is not simply drifting away, its orbit is also deforming over time. It is not just eccentric and inclined. It oscillates through complex cycles that the three-body model Earth-Moon-Sun still cannot perfectly describe. Tiny inaccuracies accumulated over billions of years can produce large discrepancies that we are not yet able to measure. All of this leads to the greatest mystery of the phenomenon, where every model stalls when trying to explain the moon's highly irregular recession history across 4 billion years. What has caused the moon's recession rate to change over time in such a non-linear, unstable, and unpredictable way? It might be a combination of many factors: the rearrangement of supercontinents, the changing depth of oceans across eras, powerful climate shifts, the evolution of Earth's internal structure, or even physical tidal mechanisms at the planetary scale that we have not yet discovered. But what is striking is that no existing model can perfectly reconstruct the moon's recession history. There were periods when the recession rate increased dramatically, far beyond what tidal forces alone can explain. There were also periods when the rate nearly dropped to zero, as if something locked the system temporarily. A controversial hypothesis suggests the moon may have gone through a complex orbital resonance with Earth, similar to resonances among moons of Jupiter or Saturn. If such a resonance occurred, it could have pumped extra energy into the Earth-Moon system, altering the recession rate over brief intervals. But this idea requires far more evidence. All of these mysteries culminate in a single open question: are we missing a crucial piece of planetary dynamics? That question still hangs unanswered. The moon continues drifting away, Earth's days grow slightly longer, and humanity keeps trying to decode the motion journal that has been written over more than 4 billion years. The greatest mystery is not just how far the moon will go, but why its journey is filled with irregular, unexplained shifts that do not align with our current scientific understanding. Perhaps the true answer lies in changes that geology never recorded, or in physical mechanisms that modern science has not yet discovered. And until that answer emerges, the moon's slow departure will remain one of Earth's most beautiful, profound, and ancient mysteries. In a distant region of the solar system, where sunlight becomes nothing more than a cold, faint streak, Saturn spins quietly in the void with its magnificent rings. Yet behind this beauty lies one of the most puzzling mysteries that has troubled scientists for more than 4 decades: a giant storm shaped like a perfect hexagon, located precisely at the planet's north pole. When humanity first saw it through the Voyager spacecraft in the 1980s, the initial reaction wasn't amazement, it was doubt. A perfectly regular hexagon with razor-straight edges on a gas giant, it seemed impossible, as if someone had literally drawn a geometric figure onto the atmosphere. But the more we observed it, the clearer it became. This wasn't a coincidence. It was one of the most extraordinary atmospheric phenomena ever recorded. What do you think could create a perfect hexagon in the chaotic atmosphere of Saturn? Share your thoughts in the comments below. Despite spanning a region nearly 3 times the diameter of Earth, Saturn's hexagonal storm maintains a symmetry so precise that it seems to defy the very nature of atmospheric motion. Each of its 6 sides forms a sharply defined, perfectly straight boundary, nothing like the curved, unstable edges we expect from storms shaped by turbulence. Under normal physical laws, chaotic forces such as convection, shifting jet streams, and extreme temperature gradients should distort any structure that tries to form. Yet within Saturn's violent and ever-changing atmosphere, this geometric figure remains astonishingly stable, as if locked into place by an unknown mechanism. The storm behaves less like a natural phenomenon and more like a vast experiment in fluid dynamics, raising the unsettling question of how such mathematical perfection can emerge and persist inside one of the most chaotic environments in the solar system. Even stranger, the storm is not stationary. It rotates continuously, with winds reaching up to 330 kilometers per hour, strong enough to tear apart most atmospheric structures. Yet the hexagon never bends, never twists, never breaks apart. From Voyager to Cassini, across decades and across centuries, its shape has remained almost unchanged. No weather model on Earth or anywhere else in the solar system has ever replicated such stability. At best, we can simulate the differences in jet stream speeds might create a kind of standing wave. But no simulation explains why that wave becomes a perfect hexagon rather than distorting, fragmenting, or fading over time. At the heart of Saturn's hexagonal storm lies a feature just as perplexing as the 6-sided boundary itself, a vast, perfectly circular vortex spinning at the center. While the outer rim forms a mathematically sharp hexagon, the core behaves like a colossal hurricane eye, smooth and round, as if obeying a completely different set of physical rules. This juxtaposition of incompatible shapes, a rigid polygon enclosing a fluid, rotating circle, remains one of the greatest puzzles in atmospheric science. Under normal conditions, the chaotic forces that sculpt the outer hexagon should distort the central vortex or vice versa, yet both persist in perfect harmony. What invisible balance keeps the circle from collapsing into the polygon, or the polygon from warping around the circle? The answer lies somewhere within Saturn's deep, turbulent layers, yet for now it remains entirely unknown. One of the most visually striking and scientifically confusing behaviors of Saturn's hexagonal storm is its dramatic shift in color as the planet moves through its long seasons. During certain periods, the hexagon turns a deep, almost crystalline blue, as if the clouds were suddenly stripped of haze. At other times, it transforms into a thick golden brown, saturated with photochemical smog under Saturn's dim sunlight. Scientists suspect that seasonal changes in solar exposure alter the concentration of aerosols and trigger complex reactions in the upper atmosphere. Yet this explanation raises more questions than answers. Why is the color transition so intense? And why is it confined almost entirely within the hexagon's boundaries? The rest of the surrounding atmosphere barely changes at all. This puzzling isolation hints that the hexagon might not simply be a storm, but a tightly sealed atmospheric domain, one with its own chemistry, circulation, and evolutionary timeline distinct from the planet around it. The lifespan of Saturn's hexagonal storm may be the most unsettling uncertainty of all. Humanity has only observed it for a little over 40 years, from Voyager's first images to Cassini's final descent. Yet during that entire span, its shape remained astonishingly unchanged. Such long-term stability hints that the hexagon might have existed far earlier, perhaps for centuries or even millennia, silently rotating above Saturn's North Pole. But how could a geometric pattern so rigid survive inside one of the most chaotic atmospheres in the solar system? Every principle of planetary meteorology suggests it should have broken apart long ago. Its endurance forces scientists to question whether Saturn harbors deep atmospheric rhythms or hidden internal processes that operate on timescales far beyond human understanding. Among all the enigmas surrounding Saturn's hexagonal storm, the question of stability stands as the most profound and unsettling. Saturn's atmosphere is a turbulent world of competing jet streams, violent temperature gradients, and swirling pressure patterns, an environment where no structure should endure for long. Under such conditions, any geometric formation ought to be torn apart, stretched into curves, or dissolved into chaos, and yet the hexagon refuses to yield. For over 4 decades of observation, and likely far longer, it has remained fixed, sharp, and mathematically precise, rotating without distortion, as if governed by an unseen architect. Scientists have proposed a variety of explanations, from Rossby waves forming a stationary pattern to extreme shearing forces in Saturn's high-speed jets that might lock the shape in place. Others suggest interactions between the massive central vortex and the surrounding currents could create naturally repeating boundaries. But each hypothesis explains only fragments. None can account for the long-term durability, the perfect symmetry, or the uncanny straightness of all 6 sides. If the hexagon were truly just a byproduct of atmospheric flow, we would expect variations, warping, or at least occasional disruptions, but none have ever been recorded. This persistence challenges the core of planetary fluid dynamics and suggests that something deeper, perhaps hidden within Saturn's internal layers, is orchestrating the phenomenon. Could the planet's magnetic field subtly sculpt atmospheric flow? Could internal rotation transmit energy upward in patterns we do not yet understand? Or are we seeing the surface signature of a physical process entirely unknown to modern science? With Cassini's final dive in 2017, humanity lost its only close-range window into this mystery. The hexagon continues to spin unchanged and unexplained, while our understanding lags far behind, left with data conjectures and a growing realization that Saturn still guards some of the solar system's most extraordinary secrets. For decades, astronomers have viewed Venus as a living hell in the solar system, where surface temperatures are hot enough to melt lead. Atmospheric pressure is 92 times that of Earth, and a dense carbon dioxide atmosphere turns the entire planet into a gigantic furnace. But the greatest paradox is this very planet may once have been a mild, watery world, perhaps even with oceans as vast as Earth's. A planet once cool, rainy, cloud-covered, and maintaining a functioning water cycle, yet today is so hot that any water molecule is destroyed within a few seconds. What happened? How could a complete ocean vanish without leaving a trace on the surface? And most importantly, could Earth one day follow the same path? What do you think actually caused Venus's oceans to disappear completely? Share your thoughts in the comments below. Advanced climate simulations from NASA and several international research teams suggest that around 3 to 4 billion years ago, Venus may have possessed a surprisingly mild environment. Surface temperatures at that time could have remained stable between roughly 20 and 50 degrees Celsius, cool enough for water vapor to condense and form thick cloud layers across the sky. The ancient atmosphere likely contained nitrogen, a moderate amount of carbon dioxide, and most importantly, abundant water vapor, the key ingredient for the formation of shallow oceans spread across much of the surface. Many models even indicate that early Venus may have had an Earth-like climate, with rainfall and active water cycles, sea breezes sweeping across dry land, and skies filled with clouds. Together, these findings paint a vivid picture of a planet that was once blue, calm, and vibrant, completely opposite to the scorching inferno we see today. The most mysterious aspect of Venus is not that it once had water, but how all of that water vanished so completely that the atmosphere today contains almost no trace of vapor. When scientists analyzed its atmospheric composition, they discovered a strange signal. The ratio of deuterium is about 100 times higher than on Earth. This chemical fingerprint indicates that water once existed and was later destroyed. In the upper atmosphere, intense solar radiation broke water molecules into hydrogen and oxygen. The lighter hydrogen escaped quickly into space, leaving heavier hydrogen deuterium gradually accumulating over time. Such a dramatic imbalance could only occur if the planet once held a massive volume of water, enough for atmospheric escape to persist for hundreds of millions of years. It was this irreversible destruction in the upper atmosphere that caused Venus's oceans not merely to evaporate, but to be completely erased from the planet. The catastrophe that erased Venus's oceans began with the runaway greenhouse effect, a threshold-breaking process so extreme that once it started, nothing could halt it. As sunlight intensified on the young planet, the oceans gradually warmed, causing more water to evaporate. Because water vapor is an even more powerful greenhouse gas than carbon dioxide, each increase in vapor trapped additional heat, which in turn caused even faster evaporation. This triggered a self-reinforcing loop, a deadly climate spiral in which heat fed on itself. When temperatures finally surpassed a critical limit, enormous amounts of water vapor surged into the upper atmosphere where they were bombarded by intense ultraviolet radiation from the sun. The radiation split water molecules into hydrogen and oxygen. The light hydrogen escaped rapidly into space, while the heavier oxygen was stripped away by the solar wind or reacted with the superheated surface to form oxides. Over millions of years of this relentless process, the oceans did not simply evaporate, they were completely erased from the planet, leaving Venus dry, scorched, and forever transformed. But the question remains, why did this process occur on Venus, but not on Earth? A key factor lies in Venus's position in the solar system. The planet receives nearly twice as much sunlight as Earth. This means its baseline temperature was already high. Only a slight change was enough to push the entire climate system past the point of no return. In addition, Venus lacks plate tectonics. On Earth, tectonic activity helps bury CO2 deep into the oceans, stabilizing the climate for hundreds of millions of years. But Venus is a closed world, no recycling of CO2. When volcanoes released greenhouse gases, all of it remained trapped in the atmosphere. And once the concentration became too high, the oceans began to boil slowly, then rapidly collapsed. Many scientists believe a series of colossal volcanic events, possibly a planet-wide resurfacing episode, where most of the crust melted under massive lava flows, released an enormous amount of CO2. The surge in greenhouse gases over a short period pushed the climate past the irreversibility threshold. This may have been the final blow that caused the oceans to evaporate completely within tens of millions of years, suggesting that climate collapse can happen faster than we imagine. Another mystery puzzles scientists. Why does Venus's surface today show no trace of any terrain shaped by water? No erosion channels, no sediment layers, no clear chemical patterns. This seems contradictory to a planet that once held water. However, the global resurfacing event likely reset everything. A massive layer of lava covered nearly the entire old surface, erasing all direct evidence and leaving only atmospheric chemistry as the last remaining clue. This mystery becomes even more intriguing when considering that Venus may once have had conditions suitable for early life. If the oceans persisted for several hundred million years, that is enough time for primitive microorganisms to emerge. Some researchers even speculate that life might still exist in Venus's cloud layer, a much cooler environment compared to the surface. The controversial discovery of phosphine reignited this debate, as the molecule is considered a potential biosignature. However, the truth remains unresolved. The mystery of Venus's completely vanished oceans is not just a scientific story. It is a chilling warning for Earth. The runaway greenhouse threshold is not theoretical. If CO2 levels on Earth continue to rise unchecked, the global water cycle could destabilize, pushing temperatures upward in a similar feedback loop. Once a planet crosses that threshold, no technology can reverse it. Venus stands as a living example. A planet once astonishingly similar to Earth, transformed into a metal-melting furnace with no way back. Today, new NASA and ESA missions are preparing to uncover the final answers. How deep were Venus's ancient oceans? How long did they last? And what exactly pushed the planet past the breaking point? Only by deciphering Venus's story can we truly understand where Earth's climate might be heading. Of all the worlds circling our sun, only one looks like Earth's twin, yet behaves like a cosmic renegade, Venus. At first glance, it seems familiar, similar size, similar mass, similar position in the solar system, but the closer we look, the more it transforms from a sibling into a stranger. Beneath its golden clouds lies a world that rejects every rule of planetary behavior, a toxic atmosphere dense enough to crush metal temperatures hotter than molten lead winds that roar like a furnace, and at the center of its strangeness, a shocking truth. Venus spins backward, not just slowly, not just oddly, but in complete defiance of the direction followed by nearly every other planet. It is a planet that looks like Earth, yet moves like something that should not exist. Why do you think Venus spins completely backward? Share your thoughts in the comments below. Even though its backward rotation is already strange, Venus's spinning speed is even more shocking. It turns so slowly that it is almost motionless in space. A single Venusian day lasts 243 Earth days longer than its own year. This extraordinary sluggishness nearly robs the planet of its ability to maintain a stable spin, triggering extreme atmospheric and thermal fluctuations. It is a profound paradox that challenges every physical model, describing how a planet sustains its rotation. But to fully understand this strangeness, we must begin with the most crucial point, the factor that has made Venus one of the greatest astronomical mysteries for decades. Venus rotates completely backward, retrograde rotation. In the solar system, most planets rotate in the same direction, like spinning a disk, due to the early formation of the solar system as a rotating gas and dust disk. Earth, Mars, Jupiter, and others follow that direction. But Venus does not. It rotates completely opposite, as if someone grabbed it and spun it, counter to the entire system. If you stood on Venus, which is nearly impossible, you would see the sun rise in the west and set in the east. The sun would crawl slowly across the sky for hundreds of days, making time itself feel meaningless. Why does Venus rotate backward? This question has driven scientific debate for over 50 years, and the unsettling truth is that there is no complete answer. Every hypothesis contains major gaps. The most widely supported hypothesis suggests that Venus may have experienced a planet-scale collision in the early days of the solar system. A Mars-sized body could have slammed into it at an extremely unusual angle, powerful enough to flip almost its entire rotational axis and transform the planet from spinning normally to spinning in reverse. This model resembles the theory of how Earth's moon was formed, which is why it was once considered a promising explanation. However, the problems appear immediately. An impact of such magnitude should have left clear traces, a moon ejected into orbit, a field of debris, or identifiable signatures within the planet's crust. Yet on Venus, none of these exist. Even worse simulations show that massive impacts typically make planets spin faster, not slow them down to the point of near standstill. These contradictions make the impact hypothesis intriguing, but still far from sufficient to fully explain Venus's bizarre retrograde rotation. Some scientists believe that Venus's atmosphere, 90 times thicker than Earth's, may have created enough friction to slow its rotation and gradually tip its axis over the span of billions of years. The immense pressure, combined with the planet's super-fast atmospheric winds, is thought to act like a natural brake that steadily erodes its rotational energy. However, modern simulations reveal that this drag force, despite being strong enough to crush metal, is still far too weak to reverse the spin of a massive planet. This suggests that while the atmosphere may play an important role, it is not sufficient on its own to explain Venus's mysterious retrograde rotation. Another hypothesis suggests that tidal forces from the Sun continuously acted on Venus, gradually slowing its rotation until the planet became dynamically unstable and eventually flipped its axis, leading to a backward spin. This idea is based on the concept that gravitational tides can subtly tilt a planet's angular momentum over extremely long periods of time. However, the biggest controversy arises from a simple question: if tidal forces are strong enough to flip Venus, then why doesn't Mercury, a planet even closer to the Sun, experience the same phenomenon? This inconsistency casts serious doubt on the tidal hypothesis and prevents it from being a definitive explanation. A bold hypothesis proposes that Venus may have originally rotated in the same direction as Earth, but powerful disturbances within its molten mantle gradually altered the planet's angular momentum. Deep convection currents, moving slowly yet persistently over billions of years, could have generated enough torque to bend its original rotational path. If Venus's mantle differs significantly from that of other planets, being denser, more viscous, or convecting in unusual patterns, these internal changes could accumulate and eventually reverse its spin. However, because we cannot directly measure Venusian seismic activity and numerical simulations remain inconsistent, this hypothesis, while intriguing, still lacks solid evidence. Here lies the astonishing part: regardless of how advanced our simulations become, every planetary formation model concludes that Venus should rotate normally just like the others. This makes Venus's complete retrograde rotation one of astronomy's greatest challenges, a choke point mystery that breaks foundational theories of how the solar system formed. But Venus grows stranger still. It rotates incredibly slowly, almost not at all. It takes 243 days for a single spin, and radar measurements show this rotation rate is not stable. Venus's rotation changes over time, as if the planet refuses to maintain a constant rhythm. This weird variability hints at internal processes we still cannot explain. Because Venus spins so slowly, a day on Venus is longer than its year. Combined with the backward rotation, the day-night cycle becomes entirely alien. If microbial life had ever existed there, adapting to such extreme cycles of light and darkness would have been nearly impossible. Temperatures on Venus reach 460 degrees Celsius, hot enough to melt lead. The pressure is equal to being nearly a kilometer underwater. Its atmosphere is filled with carbon dioxide and sulfuric acid, a true hellscape. Yet, ironically, Venus may once have been similar to Earth, but its backward rotation and near-standstill spin likely contributed to a climatic collapse, turning the planet into the inferno we see today. This leads many scientists to wonder, did the retrograde spin cause Venus to become the hellish world it is now, or is it simply the result of ancient catastrophes we can no longer detect? No one knows. No one can confirm. No one has the answer. All we know for certain is that Venus's complete retrograde rotation and its near-motionless spin remains one of the greatest mysteries of the solar system. It is a puzzle, sitting right next to Earth, yet still beyond our reach, after decades of exploration. Until humanity can build a probe capable of surviving longer on its infernal surface, the story of Venus's rebellion will remain one of science's most enduring unanswered questions. Across the entire solar system, there is perhaps no phenomenon as faint, mysterious, and challenging to fundamental physical models as the fact that Neptune, a frozen giant at the farthest edge, emits X-rays. According to every principle of modern planetary physics, Neptune should not possess any energy source strong enough to generate X-rays. It is not a star, has no nuclear fusion activity, no massive plasma storms, and no solid surface for high-energy particles to collide with and produce radiation. The temperature at the top of its clouds is around -220 degrees Celsius, nearly one of the coldest points in the solar system. X-rays, on the other hand, are typically produced in extremely hot, chaotic environments, the Sun million-degree corona supernova, remnants, neutron stars, black holes. And yet in a cold region near the boundary of the solar system's darkness, a burst of high-energy light appears weak but undeniably real. This is why the discovery has been compared to seeing lightning in a frozen sea of silence. The first detection was recorded by NASA's Chandra X-ray Observatory. No one expected to see anything because the idea of a distant gas giant over 4 billion kilometers away emitting X-rays sounded more like a measurement error than reality. But the signal appeared, extremely faint, extremely unusual, yet completely real. This contradiction immediately raised a major question. If Neptune cannot produce X-rays through any conventional mechanism, then what is the true source? And this is what makes the mystery not only fascinating, but potentially tied to gaps in planetary physics and particle physics that remain unsolved. Do you think Neptune is hiding a physical process we haven't discovered yet? Share your thoughts below. Throughout this entire phenomenon, the most crucial point is that the source of the X-rays cannot be determined. This is what troubled the scientific community more than any other planetary mystery. Planets like Earth, Jupiter, or Saturn also emit X-rays, but their mechanisms are clear, either scattering sunlight or accelerating charged particles within the magnetic field to generate auroral emissions. But Neptune lies too far from the Sun to scatter enough light to produce a measurable signal. Moreover, its magnetic field is tilted, twisted, and asymmetric to such a degree that it is difficult for it to form a stable particle trap capable of generating strong X-ray emissions. So what hypotheses have scientists proposed? The simplest hypothesis proposed to explain Neptune's X-rays is the scattering of sunlight X-ray photons from the Sun strike the planet and bounce off its cold atmosphere. However, according to the inverse square law, radiation intensity must drop sharply with distance. At more than 30 times Earth's distance from the Sun, the reflected X-rays should be so weak that they disappear into background noise. Yet Chandra detected a signal stronger than expected, not powerful, but significantly above theoretical predictions. This discrepancy makes the scattering hypothesis unconvincing and forces scientists to search for alternative mechanisms to explain this mysterious source. The second hypothesis suggests that Neptune's faint system of dust and ice rings may be connected to the source of its X-rays. These rings are so thin they are nearly invisible, made of tiny ice particles, dark dust, and microscopic debris. In theory, if high-energy particles from the solar wind or even from interstellar space collide with this material, they could generate X-rays. However, the biggest issue is that the ring's material density is far too low to produce enough collisions. They resemble a drifting haze rather than an active impact environment. This makes the hypothesis weak and lacking any observational evidence, leaving the true origin of Neptune's X-rays unanswered. The third hypothesis, and the most debated, proposes that Neptune's X-rays may originate from unidentified, high-energy particles capable of penetrating its cold atmosphere and interacting within the planet's distorted magnetic field. Some scientists even Consider the possibility of weakly interacting exotic matter or rare particle decay processes mechanisms that do not normally occur under typical solar system conditions. Although far from a confirmed conclusion, the failure of classical models makes this idea of new physics worth serious consideration. If true, Neptune could be functioning as a natural laboratory at the edge of the solar system, where rare physical phenomena unfold quietly beyond direct human observation. The fourth hypothesis looks beyond the solar system, suggesting that high-energy particles from interstellar space may be responsible for Neptune's X-ray emissions. Near the inner edge of the heliosphere, the solar wind weakens, creating a transitional boundary where galactic plasma interacts with the solar system's environment. With sufficient energy, interstellar particles could penetrate this barrier, plunge into Neptune's cold atmosphere, and produce faint X-ray emissions. However, this mechanism faces a major issue. If the source were interstellar, the signal should remain relatively stable over time. Instead, observations show irregular and fluctuating intensities, making this hypothesis intriguing, yet still unable to fully explain the mystery. Another surprising feature is that Neptune's X-rays do not appear consistently. Sometimes they show up, sometimes they don't. Sometimes they are stronger than predicted, sometimes nearly absent. This irregularity is incompatible with any known mechanism. If the source were scattered sunlight, the signal would be stable. If it were particle collisions, the signal would correlate with solar storms, but the data match neither pattern. The unusual nature of this phenomenon becomes even more perplexing when considering Neptune's extremely distorted magnetic field. Instead of aligning with its rotation axis like many other planets, Neptune's magnetic field is tilted by 47 degrees and displaced tens of thousands of kilometers from the planet's center. This asymmetry makes it nearly impossible for existing models to determine where high-energy particles could be accelerated strongly enough to produce X-rays. Yet this very chaos raises an even bolder question. Could we be witnessing a completely new particle acceleration mechanism, one that has never been described in modern science? All of this leads to the biggest question, and the one that makes Neptune's X-rays a mystery worth decades of study. Where do these X-rays come from? Every hypothesis has problems. Every model breaks when compared to real data. Every proposed explanation generates more questions than answers. The source may be a combination of multiple small mechanisms or a completely new process we have never considered. And because no existing explanation fits the evidence, the phenomenon becomes one of the most intriguing cosmic mysteries, a cold, distant, silent world emitting high-energy radiation in defiance of physical logic. A weak glimmer from the frozen darkness of the solar system, and behind it, a mystery still waiting to be solved. Among all the planets in the solar system, Mercury has always been considered the simplest, the smallest, the closest to the Sun, and the driest, most desolate surface. But when spacecraft, especially Messenger, approached it, scientists realized they had completely underestimated this world. Beneath its cold gray crust and cratered landscape, Mercury possesses a phenomenon that astonished the entire planetary science community: an extremely weak, distorted magnetic field that does not follow any known physical rule. Earth, Jupiter, and Saturn all have strong magnetic fields generated by liquid metallic cores that rotate and create a dynamo effect. But Mercury is different. The planet is only slightly larger than the Moon, and its cooling process should have solidified the entire core billions of years ago. Yet measurements reveal that part of Mercury's core is still molten and active, but it fails to generate a strong magnetic field. Its magnetic field is only 1% as strong as Earth's. It is so weak that you could compare it to a fridge magnet placed next to Earth's massive electromagnetic engine. But this weakness leads to an even bigger paradox. How can such a small planet located so close to the Sun still maintain any magnetic field at all, even a warped, fragile one? What do you think allows such a tiny planet like Mercury to keep its faint magnetic field? Share your thoughts in the comments below. First, we must understand how absurd this truly is. 60 million kilometers is the average distance from Mercury to the Sun. That means the planet constantly endures solar storms, dozens of times stronger than those hitting Earth. The pressure of the solar wind is powerful enough to crush Mercury's magnetosphere down to the surface, leaving almost no protective region. A slightly weaker magnetic field would allow the Sun to blow away everything literally. Yet strangely, it still exists. Despite orbiting right beside the Sun's immense furnace, Mercury still possesses a stubbornly persistent magnetic field, something that modern physical models struggle to explain. A small planet with slow rotation and a cooling core should have lost its magnetic field billions of years ago, yet reality is the exact opposite. Mercury's weak field remains stable, but what makes it especially strange is its significant offset, nearly 20%, toward the northern hemisphere. When scientists map this magnetic field, they find a clearly distorted structure. The north is unusually strong, while the south is so weakened that it nearly collapses. This imbalance not only reveals that Mercury's core is operating under an unusual internal mechanism, but also hints at the possibility of an external force, most likely the Sun, actively distorting and sustaining Mercury's magnetic field in a way completely unlike any other planet in the solar system. A controversial yet compelling hypothesis suggests that Mercury's faint magnetic field is not generated solely by its core, but is partially activated by the solar wind. As streams of charged particles crash into the planet at tremendous speeds, they may penetrate its thin outer shell and transfer energy into the liquid layer of the core. This force stirring could produce weak convective currents, just enough to sustain a semi-natural, semi-induced dynamo. If true, Mercury would be the only planet in the solar system whose magnetic field survives thanks to the direct intervention of the Sun, making it a unique natural laboratory for studying how a star can influence the electromagnetic structure of a nearby rocky world. Even so, the hypothesis does not explain everything. Mercury's crust is extremely thick and cold. For billions of years, it has nearly frozen solid, forming a giant lid over the core. This lid exists because the planet cooled too quickly after its formation. Such a rigid crust should prevent any convection inside the core, effectively shutting down the dynamo. Yet somehow, convection continues. The core has not fully solidified, and the magnetic field, weak as it is, has not disappeared. It is like placing a pot of boiling water inside thick ice for billions of years, and the water inside still refuses to freeze. Mercury's faint magnetic field is only strong enough to form a mini magnetosphere, the smallest structure of its kind ever recorded in the entire solar system. It is so tiny that the solar wind is barely deflected and can crash directly onto the planet's surface, something that would be impossible on Earth. When high-energy ions strike Mercury's exposed rocky crust, they trigger emission reactions that generate X-rays, a phenomenon typically seen only in extreme environments, such as the Sun's surface, neutron stars, or intense radiation zones. The fact that a small rocky planet like Mercury can emit X-rays forces scientists to rethink their understanding of how weak magnetic fields interact with solar radiation, as if all familiar physical rules bend and behave differently on this strange world. All these observations raise one big question: why hasn't the Sun destroyed Mercury's magnetic field? This absurdity forces scientists to reevaluate the entire thermal evolution model for rocky planets. Some new hypotheses suggest that Mercury's core contains more sulfur than expected, lowering its melting point. Others believe electromagnetic interactions with the solar wind may create a temporary sustaining effect, but none of these hypotheses are considered complete. When you assemble every piece of the puzzle, Mercury becomes the embodiment of a perfect paradox, too small yet possessing a giant core, too close to the Sun, yet still holding a magnetic field, too cold on the crust, yet still molten inside, too weak a magnetic field, yet strangely complex in structure, and most importantly, existing in an environment where its magnetic field should have been completely destroyed long ago. Perhaps the greatest mystery is not why the magnetic field is weak, but why it survives at all. In planetary science, the weakest things often signal a powerful mechanism we have not yet understood. Mercury keeps its secrets tightly locked, challenging us to uncover them. And to this day, it remains one of the greatest puzzles in the solar system, a puzzle that begins with the most irrational fact of all. A tiny planet right next to the Sun, yet its magnetic field still endures. When people think of the Moon, they often picture a barren, silent world that seems to have no mysteries left. Yet detailed observations reveal the opposite. The Moon is a celestial body filled with paradoxes that challenge modern scientific understanding. One of the most striking among them is that the far side of the Moon possesses magnetic regions far stronger than those on the side facing Earth. This phenomenon completely contradicts predictions based on basic physical principles. Theoretically, the near side, the hemisphere that always faces us, should have stronger magnetism because it sits directly within Earth's magnetic influence. Even if weak Earth's magnetic field should have magnetized lunar rocks over time. But measurements tell a completely different story. The far side, the region farthest from Earth and least affected by its magnetic field, contains magnetic anomalies strong enough to bend the paths of charged particles from the solar wind. These magnetic structures are intense, sharply defined, and unusually patterned, as if shaped by an unknown process never observed elsewhere. What do you think could be causing the far side of the Moon to have a stronger magnetic field than the near side? Share your thoughts in the comments below. The next puzzle lies in the origin of these magnetic regions. Geological evidence shows that the Moon once had a hot core and a geodynamo mechanism similar to Earth's, but that system stopped operating about 3.5 billion years ago. Today, the lunar core is tiny, cold, and almost motionless, with no molten metal circulation capable of generating a magnetic field. According to scientific logic, the Moon should now be considered a magnetically dead world, incapable of producing any significant magnetic activity. Yet somehow the far side retains magnetic regions that are inexplicably strong. They exist as if the rocks there had been magnetized by an immense ancient energy source that, according to current understanding, never existed on the Moon. These magnetic anomalies are not only strong, but astonishingly persistent. They have endured for billions of years without weakening, despite constant bombardment by the solar wind and the slow erosion of cosmic exposure. This contradicts everything we know. The strongest iron meteorites found on Earth typically retain magnetization for only a few million years before losing strength. Yet the magnetic patches on the Moon's far side have remained intact for billions of years, as though their fields were frozen permanently at the moment they formed. No known physical model can adequately explain this extraordinary stability. One of the most visually striking manifestations of this phenomenon is the presence of lunar swirls. These are winding, bright, dark patterns on the lunar surface that do not follow the terrain, do not align with geological processes, and show no connection to impact events. They appear brightest in regions with strong magnetic fields, as if sketched by solar wind particles that twist and avoid magnetic influence. NASA once described these swirls as artwork painted by the solar wind, but the true mystery lies beneath their beauty. The magnetic strength required to create such patterns far exceeds what the Moon should be capable of generating, especially when no known energy source exists to sustain them. This is the heart of the entire mystery. According to classical physics, a celestial body needs a moving molten metallic core, a functioning geodynamo, in order to sustain a strong magnetic field. Earth, Mercury, and several other planets possess magnetism because their cores are active, but the Moon does not. Its core is too small, too cold, and completely lacking the convective motion required to produce magnetism. And yet the far side contains magnetic regions as strong as giant buried magnets. Detecting such magnetic strength on a cold, inert rock would be like measuring a powerful magnetic field emanating from a frozen stone, an impossible scenario under known planetary physics. So where does this magnetism come from? Why does it exist? What mechanism created such immense magnetic anomalies? These questions have baffled scientists for decades. Scientists have proposed 3 major hypotheses to explain this phenomenon, yet all of them suffer from serious contradictions. The first suggests that metallic meteorites containing iron and nickel struck the far side billions of years ago and became buried beneath the lunar soil, their intense impact heat magnetizing the rocks. However, no geological evidence indicates that the impacts generated enough heat to create magnetization of this magnitude. There are no traces of molten flows and no explanation for why only the far side, not the near side, would possess stronger magnetic anomalies. The second hypothesis claims that Earth's ancient magnetic field was far stronger long ago and magnetized the Moon when the two bodies were much closer. But simulations show that Earth's primordial field was not strong enough to create such long-lasting, powerful magnetism. Furthermore, the orientation of the magnetic regions does not match Earth's magnetic axis during any known era. The third and boldest hypothesis suggests that the Moon's core was once far more active than expected. But if this were true, the Moon's core must have been larger, hotter, and more dynamic, all of which contradict current seismic and geochemical data. In other words, the hypothesis only works if we assume the Moon was once a completely different kind of celestial object. With no satisfactory explanation, scientists face an uncomfortable reality. The magnetic anomalies on the Moon's far side challenge the entire classical model of planetary magnetism. They persist as magnetic fossils, remnants of a process we do not understand and cannot reproduce in laboratory simulations. All orbital data confirms that the phenomenon is real, stable, and uniquely unlike anything observed on any other planetary body in the solar system. These magnetic regions also interact with the solar wind in ways never seen elsewhere. When solar wind flows across them, it bends and disperses, forming luminous, surreal patterns on the lunar surface structures totally unrelated to topography. This effect has not been observed on Earth, Mars, or any other world. The Moon stands alone as the only place with these solar wind paintings, and once again, they are found mostly on the far side. NASA has repeatedly acknowledged that no existing model can explain the strength, shape, or longevity of the far side magnetic anomalies. Data from Apollo lunar prospector and modern orbiters all lead to the same conclusion: the anomalies exist. They are strong, they are unusual, and their origin remains beyond the reach of current scientific understanding. Ultimately, everything leads to a single unresolved paradox. The Moon, a world with no hot core, no dynamo, and no mechanism for generating magnetic fields, somehow possesses magnetic regions of extraordinary strength, as if activated by an ancient energy source lost since the earliest days of the solar system. Until humans return to the far side, drill into its ancient crust, and directly study these strange magnetic zones, the mystery will remain intact. And the greatest question will continue to stand without an answer: why does the coldest, farthest, darkest region of the Moon hold the strongest magnetic field?